Okay, so we've got loads to get through, and I think why this panel is really interesting, because these three gentlemen are all executives working in areas where our AI is really tangible, be it steel, concrete, CapEx, or operating margin. So let's just get brief intros. Let's start with you, Christian.
I'm talking about myself. So I'm a geek turned VC. This is my fourth of these. Maybe if we include WebRazi, my 10th of these. So good to be back. So I run a firm called 2150 VC. We try to make the physical world more efficient, resilient, sustainable, from hardware to software, applied AI, all the way to robotics, investing across the Atlantic, half in North America, half in Europe. All the team is based here. We're a Series A investor primarily. And these guys are two great examples of companies that we know well, working in the physical world by doing applied AI.
Okay, that's brilliant. Greg, can we do a 1-minute concise overview of nodes and links?
Sure thing. So nodes and links is artificial intelligence for complex project management. We automate a lot of the analysis and decision making around time to do with some of the biggest builds. We do data centers, chip fabs, nuclear build outs, network grids, ports, airports, roads, rail, all of these kinds of things. We're in 23 countries at the moment, just past $500 billion of projects under management, and we focus on acceleration and risk mitigation. So we're approaching about a millennium of project time saved in terms of acceleration or delays prevented across all of those industries. We're seeing a lot of growth in energy, data centers, and chip fabs right now.
All hot topics. And finally, can we get Noah? Can we get a 1-minute overview too, please?
Absolutely. So Noah Miller, CEO of Carbon REIT. We build control systems to run cement plants, which is not the most exciting thing on the face of it, but there are something like 3,000 cement plants across the world. Cement is the second most used material on the planet after water and accounts for 8% of global emissions. And these plants are insane. They're sort of huge 160-meter, 100-meter kilns that turn big rocks into smaller rocks at 1,400 degrees and burn hundreds of tons of coal and other nasty stuff every day. So we work to make that more efficient, reducing costs for the operators and carbon for the environment, working in over 10 countries across the world, India, Turkey, Middle East, Europe, and America as well.
Okay, no, that's brilliant. So as I mentioned in my intro, you three guys are really at the coal face of things. So Christian, let's start with you. From your vantage, where do you see the strongest evidence that deep applied AI is moving from demo to durable value?
Yeah, I think the interest today when we're thinking about who to invite into the panel, right, was this. There's a lot of talk right now about real-world models. So large language models applied to the real world, like literally robots being trained by humans to do the work. But what I wanted to highlight today with these two founders, and they're obviously the center of attention today, is that these companies have already scaled. They're already using applied AI to influence the real world, the largest industries from infrastructure to cement and concrete and other industrial applications. And they're using PhD level AI models to do so, but they have to be very specific proprietary models because they're being applied to legacy controls that are analog, not digital, or at least not very digital, to processes that are actually building massive things over many, many years, and they're just honestly chucking Claude at it is not going to solve the problem. We've been looking at applied AI as an industrial optimization process for many years. I mean, we invested in you guys in 21, so it's not a new thesis for us. It's simply knowing that all these industrial processes have data lakes. Those data lakes are quite unique to that vertical, and that a knowledge of that vertical and that industry is required to be able to build the right models to then get benefits. And by the way, those benefits are not only economic, they're also planetary.
Okay, so yeah, so Noah, I mean, from what Christian said there, you were kind of ahead of the curve when it came to AI. What is the one operating decision inside a cement plant that is better when AI is involved then?
Yeah, we've been doing this for 5 years now, and for the first 3 years we got weird looks, and the last 2 years everyone's very excited. We primarily focus on the decision of what fuel to burn. So if you can reduce the amount of fuel you use in total or increase the amount of sort of alternative fuels, which is a very nice way of saying rubbish and all sorts of other nasty things, you can reduce the costs and you can increase, or you can reduce the amount of CO2 emitted. But the more you do that, the more difficult the process is to control. So you need to take huge amounts of data, make calculations, and understand trends and information that's impossible to do as a human. And so you need to use AI and machine learning to make those control decisions.
Okay, and cement's got massive emissions footprint, hasn't it? I mean, what evidence is there? How can you talk a bit about how you've kind of touched on it, how the platform is helping reducing emissions?
Yeah, absolutely. So the primary thing that we try and do is reduce the amount of coal that goes into the burner, because for the plant, OPEX is about 40 to 50% of their OPEX is fuel. That's literally millions of dollars worth of fuel over years. And so we kind of run these control systems to say, how can we reduce the amount of coal used while keeping product high? And we'll do our tests are using the system on, using the system off, literally looking at how much coal is left in the yard and saying, what was the difference? What we see is that we can easily have 10,000 tons of CO2 effect per year running our system with sort of 2 to 3% reduction in fuels that they burn.
Okay, Greg, what's the one workflow that used to be manual, slow, or error-prone, but now that AI is meaningfully improving?
That's a very interesting question, actually, in project management. So it's not one workflow, it's many. But I'll put it under the banner of orchestration. So project management fundamentally is optimization of an interconnected system under constraints. And once a system gets sufficiently large, so for example, a data center, you're looking at between 6,000 and 9,000 individual build activities, interconnected by about 15,000 interconnections. Right. And I'm working on a plant at the moment that's currently building 9 of those factories next to each other. So that goes past 100,000. When you're trying to optimize that system for time, so it's how can I build this thing as fast as possible with as little waste as possible, that inevitably is just an enormous computer simulation. And then what you have feeding in every single day is real delivery data. So nothing ever gets delivered exactly how you think it's going to be delivered. Things take longer, things take shorter, risks emerge, designs change, etc. So you have to constantly adjust this non-linear system to try and keep the projects on track.
Okay, no, that's great. So I guess one theme here is across all your areas, we're saying introducing AI can be, if it goes awry and wrong, it can be costly and expensive. I can imagine construction delays, plant inefficiencies, and underperformance. Can you talk a bit about this and how can you cushion those? To what extent can you cushion the AI going awry and the problems? I mean, do you have to do more due diligence? Any, please. Christian.
Well, maybe let's start with the scale of how these the scale of the market, right? I think why the TAM, if you will, is big. I think I'm going to quote this wrong, so correct me, Greg, because it came from your pitch deck many years ago. Think about the trillions of dollars that we spend around the world building bridges, roads, data centers, energy pylons, et cetera, literally trillions per year. 8% of the world's infrastructure projects are delivered on time and on budget.
Yep.
8% of the trillions of dollars are delivered on time. And by the way, overrun means dollars wasted, but it also means people having to pay for that overrun. So we'll start with just even fixing that. The biggest issue is that right now that risk is introduced by humans. Fine, there are models out there that actually try to just throw in the AI and say this black box of AI is going to predict the risk. Pretty hard for a human to accept that, right? Because so much money is at stake. I think what Greg did well with Nodes and Links said is not replacing a human, it's giving a human AI superpowers to optimize for that outcome. In the case of Carbon Re, these plants are running on these legacy systems and controls that are humans overlooking, and they're looking for errors, but it really is hard for a human to compute. With this combination, he was being generous by saying garbage. It literally is poo. There's actually the garbage and poo going into the kiln to burn to actually make the cement that you then use to build your house. The chemistry just completely changes, and the guy who's operating the factory just can't compute it as well. So it's actually risk mitigation more than risk creation, but you have to overcome a very legacy buyer, a very laggard industry, not very digitized, and both of them actually sell to very laggard industries with something that's quite cutting edge. So pass it over to you guys, but I think maybe change the question a little bit. How do you sell to these laggard industries that are not very digitized?
I'll trust your authority on the subject.
So people say that the construction industry or the projects industry is slow to adopt innovation. And my response to that is, no, it's just the wrong innovation. So like blockchain, what's that going to do for construction? Like nothing on the core value processes. But the two technologies that are going to do a lot are robotics and artificial intelligence, because one is physical world and one is the paperwork world. When we approach these large industries, there's kind of two approaches. Number one is that right now, a human always makes the end critical decision. So there's an override. The human can say, with my experience, with the context I know, actually, we're going to do A, not B. The second is actually assurance and auditability. So we've paired a lot of the AI with the historic deterministic and stochastic models about how they forecast how things would work, such that you can have a full audit trail about what decisions are being made and how they're being made by the AI. So it's really just an enormous assurance backbone along the system so that everything can be proven.
Okay, Noah, I saw you diligently making notes before.
I just make sure I remember all the clever things other people have said. I think one thing that's interesting for us on the sort of sales challenges is that we are, the buyer and the user are not the same person. And for us to be successful, we have to get both of them on side when they have potentially quite different ideas of what success is. And so lots of the buyers see the need to innovate, see the need to build a better set of tools to drive these old and very manual systems. But the operators ultimately are responsible for safety and if something goes wrong. So how do we have to spend a lot of time in the control room understanding their problems, understanding what they see as the biggest issues in their plant, and then building the trust with them through a lot of sort of explainability, how we sort of build out our controllers, our sort of decision-making systems so that they can understand why the system has done what it's done, and in fact, contribute back to it. Say, actually, I think we should have done something different here, and then build a self-learning system where our sort of AI can continue to learn from that. And I think that idea of safety, coming back to the first question, is, as Christian said, really about sort of managing risks sometimes introduced by humans. No one would say flying a plane without autopilot was safer than flying a plane with autopilot, but most of these plants are running without autopilot. And so we're here to help them run more safely for longer and give the operators the set of tools they need to make the best decisions.
Okay, so just if I've got this right, I mean, as the models advance and get better and better, you don't envisage humans being, there'll always be a human in the loop to some extent then?
Not necessarily. I think, there's a lot of automation going into manufacturing, especially in China. I think Europe absolutely requires more automation to produce at the scale we want to continue producing. There will be humans making economic decisions, and that human can be aided by an AI system to make the best possible decision. And I think these are two examples applied to different industries. The role of algorithms talking to algorithms will happen. I just do think that we will still want to have some level of oversight and critically traceability and accountability. Why did the algorithm make that decision? Because somebody's going to be liable for it.
Greg, where do you stand on human intervention in AI?
I just see it as a systems problem. So it's, historically I had one unit of value, which was the human, which had particular skill sets and particular diversity of thought, etc. And now I've got 2 units of value. And the question is, how do I construct this complex system together to get more of the good things and less of the bad things out of the system? AI can, or just computers and automation, can do thought work much faster, much longer, and much more precise than humans. But humans can hold legal accountability. They can set guardrails, etc. Machines today can't hold legal accountability. So it's how do you structure that to just optimize?
Noah?
Something we see for a lot of our customers is actually a problem that they don't have the operators. Their old skillful, knowledgeable operators are retiring, and there are not many 21-year-old graduates that come out of university and go, I want to run a cement plant. They should. It's really cool. I am a PhD in chemical engineering, so I have a certain bent, but very few of them do. So different sort of large cement producers are thinking about this differently. Some do want to go more down the automation route. Some want to go more down the operator enablement route. But ultimately, all of them need more skilled operators than they currently have. And so they have to rely on these sorts of autonomous systems to help with their production.
Okay, Christian, we're running out of time. Just quickly, how do you, with your investor hat on, how do you evaluate whether an AI startup in an industrial or infrastructure firm has a real moat in 2026?
In 2026, well, yeah, it's definitely changed from 21 to now. I think a thin layer or a vertical layer applied on somebody else's LLM, so a kind of an app on top of Claude, would be hard for me to back, because at some point these companies start verticalizing. There's already legal apps on Claude displacing paralegals. The data itself, what data is proprietary and what data can they actually defend once they're in, and then the market, right? So how quickly can this market adopt it, especially when, in this case, both of them, laggard markets where the upside is huge because you're actually starting from a low digitization to a higher penetration. But finally, like any VC and any investment, it's all about the team. Is this team the right team to go build that AI tool for that vertical in aggregate?
Okay, Greg, I realise you're not a VC, but in applied AI, where do you think the moats come from? Where do you think?
I can't give a generalist answer. What I can give is my specific industry. So the knowledge of how you orchestrate these projects is not widespread. It's a very, very niche discipline. So for example, my background, I was an astrophysicist that then became a nuclear submarine engineer, specializing in building the interconnected weapon systems of the British Astute class. Like, that is a very rare training, and not many people have that level of training. Similarly, my co-founder followed a same kind of dimension. What I'd say there is how you then know how the industry for the last 50 years has built the models and how you would audit them and how you assure them and how AI needs to behave within that system. That level of knowledge really is the moat, and eventually the algorithms are the moat.
Noah?
I think the modeling is just one aspect. It's taking the data from the real world, doing the right thing to it, and then having the right impact back in the real world. And we look across, particularly talking to our customers on the sort of build versus buy decision. You need the cement understanding, you need machine learning, PhDs and researchers, you need control understanding, and then you need software engineering to put all that together. And it's really bloody hard to make that all work together, excuse me. And it's not, the moat is being able to do it and having those systems that do it and do it repeatably, having that impact in the real world, not just bits on a screen, is a really big leap for anyone to make. Okay,
and Greg and Noah, I asked this question on my previous panel. Can you just talk about your staff and how kind of well-versed they are in AI? How AI competent are they? Is there any of your staff who aren't AI competent at all? I mean, or is it just a prerequisite now?
They're VC.
Yeah, since the beginning of the year, it's really been a prerequisite for all our engineers and for everyone we bring in. And there was a real step change sort of November, December last year, where these tools went from nice and interesting to critical. And so now that's what's expected of everyone.
Yeah, since day one, our data scientists obviously were very, very deep in AI. I'd say that over the last 2 to 3 years, it's then ballooned into software development and even sales. So every sales and ops person in our company now must use it, or that's just a rule.
Okay, right, that's great. That's everything. If you can all give a big thank you to my esteemed panelists.